Right now, without you even having to think about it, without you doing a single thing, your heart is beating. It's probably beaten over 100,000 times today alone. If you've ever pressed two fingers to your wrist, felt that constant, rhythmic drumming, and wondered how that incredible machine actually works, well, you're in the right place. Welcome to The Explainer. Today we're unpacking a hidden, built-in electrical system sitting right inside your chest that is literally keeping you alive at this very moment. Let's get into it.
So what exactly tells your heart to beat? I think a lot of people just naturally assume the brain is the conductor of this whole orchestra, right? Like it's constantly firing down signals saying beat, beat, beat. But actually, that is a massive misconception. To really wrap our heads around the sheer scale of the heart's workload, just consider this number, 3 billion. Your heart is going to beat about 3 billion times in your lifetime, and it will never, ever stop to rest. But here is the crazy central mystery we're unlocking today. Your heart doesn't actually need your brain to generate those 3 billion beats. It has its own, totally independent, self-powered spark generator.
Section 1. The autonomous spark and the pacemaker of the heart. To figure out how this works, we really need to start at the anatomical source of this electrical journey, which is tucked securely away in the upper right chamber of your heart. Right up in that upper right chamber, there's this tiny cluster of specialized cells called the sinoatrial node. We usually just call it the SA node. Think of this as your heart's natural pacemaker. These SA node cells possess this absolutely incredible trait known as automaticity. Basically, they do something no other cells in your body do in quite the same way. They generate their own electrical impulses entirely on their own, in a perfect rhythm. They don't wait for a signal from the brain. If you were to completely disconnect your heart from your nervous system, it would literally just keep beating on its own. And when you're just sitting around resting, that SA node sets the pace by firing off a spark roughly 60 to 100 times every single minute. It's kind of like dropping a pebble into a still pond. The SA node creates that initial spark, and then the electrical signal spreads like a ripple right across the walls of the atria, which are the two top chambers of the heart. That electrical ripple is what tells those upper chambers to contract together, physically squeezing blood down into the lower chambers.
Section 2. The electrical highway and why timing is everything. You see, a signal just spreading randomly through the heart muscle wouldn't really be enough to keep you alive. The heart needs unbelievably precise timing. If the top and bottom chambers just squeezed at the exact same time, the blood would just crash into itself with nowhere to go. So there has to be a dedicated, structured conduction system.
Let's actually walk down this biological highway chronologically. We started step 1, the SA node. That's where our autonomic spark is born. As that signal travels downward, it hits step 2, a critical little checkpoint called the atrioventricular node, or AV node. From there, it's on to step 3, racing down this pathway called the bundle of His, which quickly splits into left and right branches. Finally, it hits step 4, spreading out through a super fast network at the very bottom of the heart called the Purkinje fibers.
Now the most crucial moment happens right there at step 2, the AV node delay. When the electrical signal hits the AV node, it deliberately hits the brakes. It pauses for just a fraction of a second. And I know a delay in such a fast-paced system might sound like a design flaw, but without this tiny pause, you wouldn't survive. That split-second delay gives the upper chambers the exact amount of time they need to totally empty their blood into the bottom ventricles, right before those lower ventricles get the signal to contract. Once past that critical delay, boom, the signal shoots down the bundle of His and explodes into those Purkinje fibers. This part of the highway is built for pure, synchronized speed. The electricity races through these fibers to make absolutely sure both of the bottom ventricles squeeze powerfully and together at the exact same millisecond. That highly coordinated squeeze is what actually launches blood out to your lungs and to the rest of your body in one massive unified beat. Section 3, the brain's tug-of-war and adjusting the pace. This brings up a pretty logical question, right? If the heart is completely autonomous, as we've been talking about, why does the nervous system need to be involved at all? Why does the brain care? Well, because your body's demands are constantly changing. You're not always just resting. Your SA node is amazing, but it needs instructions on whether to speed up that baseline pace or slow it down based on what you're doing. To manage this, your autonomic nervous system steps in with two competing branches. Think of it like a gas pedal and a brake. On one side, you have the sympathetic nervous system. When you're exercising or stressed or scared, this system releases chemicals like norepinephrine that physically hit the gas and speed up the SA node. On the flip side is the parasympathetic nervous system, which operates mainly through the vagus nerve. When you're chilling out or sleeping, it releases acetylcholine, which hits the brakes and slows the SA node down. So your heart rate right now is literally an ongoing biological tug-of-war between these two systems, constantly tweaking your heart's natural rhythm to match exactly what you need in this precise moment.
Section 4. Reading the invisible signals and translating the journey.
We've talked all about this invisible electrical highway inside us, but how do we actually know it's working properly? Well, medical professionals have a pretty genius way of making this invisible journey totally visible to the outside world.
They use an electrocardiogram, or ECG. You've definitely seen these on TV or in a hospital, the monitor with the squiggly lines. Every time our little spark travels the highway, it creates a very specific pattern on that graph. The first thing you see is the P wave, a small bump. That correlates perfectly to step 1, the signal spreading through the upper atria. Then you see that massive sharp spike, the QRS complex. That's the huge surge of electricity ripping through the Purkinje fibers to forcefully contract the big bottom ventricles. And finally, the T wave at the end. That's simply the heart electrically resetting itself, repolarizing, getting ready for the next beat.
Doctors aren't just looking at these lines to make sure you have a pulse. It's a highly precise diagnostic map. By analyzing the exact shape and timing of the P wave, the QRS complex, and the T wave, a doctor can immediately see if there's an abnormal delay at the AV node, or a physical blockage in one of the bundle branches, or an irregular rhythm and arrhythmia happening somewhere along the line. If the physical highway inside your heart gets damaged, those electrical waves on the paper literally change shape.
Section 5. The ultimate engine and the elegance of the system. I want us to zoom back out from all these microscopic details for a second. Because when you put all these pieces together, the autonomous node, the deliberate delays, the superfast fibers, the tug-of-war, you realize we're looking at a wildly elegant biological machine.
Just think about the scale for a second. Your SA node, this master spark generator, is smaller than a single grain of rice, yet it generates the electricity that keeps you alive. It fires every single second without you ever thinking about it, without ever taking a vacation, from the months before you were even born until the very end of your life.
And that total autonomy, it leads to what I think is one of the most mind-blowing realities in all of medicine. This entire system is exactly why a heart can be removed from a donor, placed into an entirely different person's chest, and just start beating again on its own. Because that vital spark doesn't come from the brain. It's built right into the heart tissue itself. The engine literally brings its own spark plugs. And the workload of this tiny engine? It's staggering. 60,000. That tiny electrical system, perfectly coordinating those 4 chambers, generates enough physical force to push your blood through 60,000 miles of blood vessels every single minute of every single day.
So the next time you happen to notice your pulse or hear your heartbeat when you're lying in bed, I want you to remember what's actually happening in there. A self-generating spark of electricity is racing down a highly tuned biological highway just to keep you alive. Which really leaves us with one final thought. If your heart is doing all this without you asking it to, what other automatic miracles is your body performing right now, entirely under the radar? If you found this breakdown fascinating, make sure to stick around for our future explainers. We're going to keep diving deep into the hidden systems that make life possible. Thanks so much for learning with me today.